Okay, so we're now on to the final segment of Mike Acton's talk. And I'm going to jump past the examples just to go to the questions. But I wanted to quickly explain sort of why I'm doing that. And just to be clear, I am in no way trying to pick on Mike with this. I actually think that this is like a really great talk. I'm super compelled. I think he did a fantastic job, and I really like the direction in general that he's leaning. But I wanted to just share sort of the way that I think about these things. And generally speaking, I've been in similar situations where I'm trying to compel an audience, like he is, with sort of a big idea. And I think his presentation on this is fantastic, right up until the example part. Generally speaking, what I find this is just the way I do it personally. So again, Mike sounds like he's super awesome team lead, technical person, visionary, and engineer. Maybe not researcher. So this isn't a judgment on him. I do kind of like both these things. And so I just wanted to share the way that I generally approach stuff and why I'm going to skip the examples is usually what I find is when you present these powerful ideas, you want to have maybe one or two quick examples to ground the audience so they understand that the things that you're saying aren't totally crazy. And I think that Mike's done a fantastic job with this, is that he presented a bunch of interesting viewpoints, and then he compelled us, I think, with one or two really powerful examples. And then he continued on the examples. Generally speaking, what I would do in this case is, and I'm going to show you an example of this is so I these are let's see, these are two of my colleagues at I think Jonathan's at MIT now, and Alvin, yeah, he's at Berkeley, I believe. And then this is a student that I jointly advised with. Let me rephrase. I was on his PhD committee, so I wasn't an official advisor. Just super clear. But I think he worked at Intel Labs with us under my in my lab, and I'm a huge fan of his work. I think that he's fantastic. I think when I was at Intel Labs, I was trying to get him to join us, but I think he ultimately chose Adobe, which makes a ton of sense. So what I'm trying to say is, uh, these two fellows are professors, and they're amazing. I love working with them. And then this was the PhD student that Alvin was advising, and then the rest of us were sort of just helping. Anyway, so in this paper, Moz is trying to show how you can use a fusion of a whole bunch of important things. Uh, I don't really have the time, or it's a bit of a distraction to go too much into the detail on how this all works. But just know that this is an idea that's going to essentially make things faster. Very similar to what Mike is arguing, is his data oriented stuff is like, oh, sort of data is the key problem, maybe not computation. And so the better you can be cache aware and do all these things, the more efficient your system. And absolutely. So, in a similar lens, this example is essentially showing you the higher order picture of how the Dexter system works. So, this is Dexter, and then it's going to take some of this original C code, and then it's going to do some interesting synthesis, and then it's going to generate some halide code, which is over here. Halide is a different programming language that is, it has a very clear separation between the what they call the algorithm and the schedule. The algorithm is meant to express the intention of what you're trying to do. So you're trying to do a blur function, and that is what is going to be captured in the algorithm. It will specify as it will specify as little as possible to express the intention. That's the purpose of the algorithm. It intentionally elides away things related to hardware because those are implementation details, and that's where the scheduler comes in. And so you can read more about this. This is a brilliant paper. I think it won a best paper or something. And I don't mean to, but let's just say that there's a lot of PhD students out there. Maz Ahmad is a very special one, so much that I basically begged to be on his PhD committee. Now, this is an example of how the system works, which is similar to what I think Mike was showing. And it shows you this, but it doesn't necessarily get directly into the performance. And I think at some point in this paper, they start to do this. But then after they set up that straw man and they kind of explain, like, here's kind of the picture, and then it's going to take this code and it's going to generate this code, and then it's going to be faster. When they start to get into the performance characteristics, they don't compel by anecdotal data. They compel by quantitative analysis. So they get to the point to where, like, okay, so now you want to see actually how this thing performs, and boy, oh boy, it's oh, of course. Uh, so then they show it. Now, what I think is important here is they're showing how it explored these like 32 candidates that does automatic performance improvement for, I think it's ordered by their x86 speed up. Yeah, so x86 performance improvement. Also keep in mind that the original code, in some sense, was already ninja level code. By ninja level code, for those of you that aren't in the super uh, expert level software development space, ninjas are people that they're they're folks that deeply understand hardware, they deeply understand software, and then they can construct algorithms that are almost at the bare metal level. So they tend to be called ninjas in these circles. So the point is that this is already the original code was already ninja level code. And then what they're showing is that when they sent it through Dexter, it made things geometrically, the geometric mean faster, 3.36x. That's on average. So what they did is like, here's all the performance improvement or loss. So these first ones over here, this is making things slower. So it doesn't always work, right? That's good, because if it always worked all the time, people would probably be like, huh, that sounds maybe like cherry picking. Does it really always work? No, things don't tend to always work. But in a large majority of cases, it does work. And then in some cases, it works extremely well, almost 2 orders of magnitude well. That's almost 100x well. But then on top of all this data, then they show, but on average, the geometric mean is it's going to improve things by 3.36x, which is approximately 240% performance improvement, if I'm understanding it correctly. Now, notice that the reason why I focus on this is they have tried to compel through anecdote and at a high level when they first start, right? This is sort of what I think is a very good idea. You start with, here's the original C Ninja code, and boy, this is complicated, and this is already cache aligned, very much like what Mike is saying. And then they're like, but look, if you translate this into Halide, Halide is an intentional programming language. In fact, I would argue that Halide is potentially the most advanced intentional programming language that exists in the world based on what I know. The only other one that comes even remotely close is like SQL. And by intentional programming language, what I mean is related to 3 pillars. And if all of this is news to you, we don't have time right now to get into it, but check out the 3 pillars of machine programming, and some of this might start to make sense. But the point is that after they show this example here, and then they show how it would translate it. This is all done automatically. Then they say, okay, but don't believe us from the anecdotal data because that is just a one off. We could cherry pick. Now let's look at this use actually across a whole bunch of cases. This, I think, is on the order of something like, I thought it was on the order of hundreds of, I thought it was hundreds of functions. Give me a second. Okay, so they first start with 5 library functions. It took them not too much time. Second stage. 32 potential schedules. So keep in mind the 32 that's not the number of functions, that is the number of different schedules they looked at. The schedules are the rewriting of the code so it's optimized. And they're looking at 32 different schedules because some of them might be good, some of them might be bad. So they don't just generate one. And then they sort of pick the one that is potentially the best. Of the 7 translated operation. Where is it? Here we go. It's right here. So they applied Dexter on 3 suites of image processing functions in Photoshop, Adobe Photoshop, consisting of 353 performance critical functions. Cool. Now I know in some sense that this generalizes. So this is like one of those things that, and again, I'm not faulting Mike. I just want to be super clear. I'm not beating up Mike and saying what he's saying doesn't make sense at all. I promise I'm not doing that. What I'm saying is that this is a really good start. And now, if we want to take this further, the next thing that we probably need to do is move away from anecdotal data and then show in a set of experiments across somewhat robust sample space, maybe a few hundred functions or a few thousand functions, that this approach does in fact generalize. And then we compel a much wider audience because they no longer think it's a one off. They start to see that, oh, wow, this is actually okay, right? So this is why I'm skipping the rest of the anecdotal examples that he has. It's not that I don't believe him. I believe him. I think it's great. And I'm very compelled. But I think I'm so compelled now that I don't need to see additional examples. I believe him. And now I want to just get to the generalized stuff or the questions. Okay. Now back to Mike. And great job, Mike. I really, really, really like this talk.
So we have a few minutes for questions, tomatoes, whatever.
Hi, excellent talk. Thank you very much. I have just a couple questions. Regarding the beginning of the talk where you said you don't use STL, you're against templates and all those things. I'm not here to throw tomatoes at you. I just want to understand the...
He didn't say he's against templates, just to be clear. He said that templates should be kind of used sparingly, and you need to kind of justify their existence. So just like I think he did a pretty good job being nuanced about this, unless I misunderstood. So he did say they don't use the STL, yes, but he did not say that they're against templates. He just said like, yeah. Anyway,
how do you then deal with a code duplication that you will get into if you don't, use templates to replicate functionality that you would use across a library?
generic programming.
The second question is, all the examples on optimizing for the cache line are extraordinary. It's very, very interesting. I totally agree with that. But I find it extremely hard to do when we're in different platforms that are not, we don't have any idea where the program is going to get run and how big the cache line is going to be or anything like that.
Okay, sorry. Let me interrupt you before I get lost.
All right.
First one, templates. How do you remove code duplication? Well, one, it's almost certainly not as big a problem as people think it is. They invent things to duplicate in order so they can invent templates to solve the problem. But in the cases where it is potentially useful, you can also generate the code. Like a template is just a poor man's text process. Like we have tons of stuff that processes text. Like you can actually do a really great job with some other tool that does it better, right? You don't need templates in order to solve that problem. So that's one.
That sounds like macros to me now. By the way, I was thinking about this last night after the videos, but I had to stop at the end of the third one because the dog and I needed to go for a run. But I thought about it some more and I realized that I wasn't quite complete with the 4 ways that you could do generic programming. Is that you could do void pointers, you could do templates, you can do inheritance, you could also use macros. And I forgot to mention macros, uh, but I thought about it last night. And then I thought, I wonder if he's using macros. And that one is, I've done generic programming with macros. I have very mixed feelings about macros. We'll just leave it at that. Okay.
Question. The other question was, I have so many platforms and I don't know the characteristics of those platforms. That's not true. I mean, it may be true you don't know, but it's not true that there isn't a finite set of characteristics, there's a finite set of range, right? It's going to be
I disagree with him. I think that this is not a good answer. I feel like I'm going to foster goodwill, but I personally would have handled this question slightly different in that I would say, totally hear you, bro. Absolutely hear what you're saying. For us, we're principally targeting consoles. And so there's just 2 consoles. We have the PS4 and we have the Xbox. So while for your case, you might be dealing with 100 variants, for us, we don't have to. And therefore, the memory constraints and the architecture constraints are different. And that's what I was saying earlier. I'm pretending like I'm Mike, and I'm saying that's what I was saying earlier is that we're solving the problems that are important to us. And for us, we build games for console, and there's only 2. So yeah, your mileage may vary, but that's the problem we're dealing with. But I feel like it's slightly disingenuous to not acknowledge the point that he's making. There are an enormous variety of different machines that have and all of these different setups, and that's part of the reason why video game developers focus on consoles is it narrows the scope so they can be zoomed in on one of these. So I haven't heard his full response here, but minimally I'd probably give him a little bit of a L, at least on this piece. He could totally handle this gracefully just by saying, "Yeah, man, I get it. There are, but for us, it's not an issue."
be within some range. You should know the min, you should know the max, you should know the average of the range of the things that you're likely to be dealing with. You should know the common case. It's not likely that that you're trying to solve the problem well for both. Again, like you're not going to be putting the same solution on, say, a Z80 and on Google Server Farm, right? It's unlikely that this is going to solve that range of problem space. So what is the finite space you're working with? What is the finite set of say chip design that you're going to probably be working with? What are the requirements for those? Does it even require an MMU? That sort of thing. Like there is this finite set of requirements that you have to have. You need to articulate them. You need to understand what that range is. Because this sort of idea of general portability is a fool's errand, honestly.
Thank you very much.
I'll skip over here and then come
Eh.
back.
Hi, have you written any tools to help you identify these sort of problems? And will you share them with us if you have?
I mean, we have lots of sort of ad hoc tools. We also do some analysis and stuff, with our performance, we can look at it and we can reason about it. But generally speaking, I mean, when you're looking at the basic level, how am I using cache lines, right? That's a pretty easy thing to reason about, right? Whatever the profiler you're using is can probably tell you your cache miss rate. right? And so you can take your cache miss rate on a particular function over a particular set of time and just look at the number of reads that you're doing and just calculate it. How, given this many reads and given this many cache misses, how much of this data am I actually using it, right?
In theory, sure. The challenge is all the functions in the world. Which ones matter, right? So,
Right?
but by the way, I just want to share answering questions, especially really complex questions live, is very challenging, right? This is this is like a super skill for people to develop. And so it's entirely possible that after Mike has thought about this, he's kind of like, oh, I kind of I get the sense that Mike is a very deep thinker, and he probably watched this over and over. And again, I don't want to. I'm not him, but maybe a better way to phrase this is when I was first in my career. Actually, when I would give talks at BoostCon when I was still a PhD student, there'd be like standing room only. There'd be all these people, and I would talk about transactional memory. And that part I think would be pretty compelling. Like people would be like, wow, this is the future. Let's do this. And then I would get questions. And I think I didn't do that well with the questions because I struggled with the ability to deal with the sort of the pressure of all the people and then turning off all the noise and zooming in onto what is being said here. And I don't know that I have this solved now. I think that this is I don't know if anybody has this solved. But I just wanted to share that I'm kind of giving Mike like a little bit of a two not loving these responses. And the reason why I'm doing that is I'm just trying to share honestly what I really think. But I also want to be fair and say that presenting material that is practiced and is well understood is easier oftentimes than dealing with dynamic questions that you don't know what will be thrown at you. And he's already spoken for an hour. He's probably somewhat exhausted. And, dealing with these things in a super graceful way it's, eh, yeah, it's not easy to do. And I actually love this question. This is actually why I am very much doing machine programming, right? It's sort of like I think of Mike and I as kindred spirits. Is I think he and I are both seeing similar things. I speculate that perhaps one of the fundamental differences that I have is I realize how hard this is, and understanding how to reason about cache lines or know which functions to concentrate on is a very challenging thing that only a small number of programmers to begin with can even start to do. Now, admittedly, I would expect that hardcore C++ people could probably do it. I mean, if there's a group of people, it's probably them and the diehard C folks. And this is no disrespect for the rest of the world. But even then, trying to hone in on how to distill out the noise of the other functions that they could be optimized, right? But they're irrelevant because they're not the hot path. So I think that's a really good question. And I think we do need tools that identify these problems. And that's part of the reason why we created Merly. Like literally, that's it. That's part of the reason why I was on Moz Ahmad's PhD committee doing the Dexter system, because it's automatically optimizing uh, for the things I think very much that Mike Acton is talking about. And I think that trying to expect that humans can do this ninja level thing, especially at scale, I think that's probably a fool's errand. I think it's well, for someone that is as brilliant as Mike and he's clearly brilliant. I suspect in his mind, he's probably like, why can't other people do this? I think it's so easy. But he's probably misunderstanding that, like, not everybody is Mike Acton, right? And he's probably so humble that it's like, I don't understand. Like, I'm just a normal guy and I can do this. So why can't you? But the truth is, like, he's not a normal guy, right? He's giving a keynote address at CPPCon. This is a big deal, right? He's like the head architect of all these things. He's a one off. He's a one off. And uh, so we probably need tools to do this, not hand wave this away and say, you can just do it on your own. Just like look at the cache lines and yeah.
It doesn't require a real sophisticated set of tools.
Thanks.
Yes.
I just wanted to ask, let's say I have a large code base that was developed with a mindset completely far from the oriented design. Do you have any tip or resource that can help us get into the right mindset and understand how can we fix that code base and expand upon it using this kind of design?
How do you fix a code base so that, is a gigantic code base that hasn't reasoned about the data at all? One step at a time. Like that's all you can do. Right? Take one step at a time. I would say, pick anything at all. Start anywhere and start to reason about it, right? Dump out the data, reason about, the actual information density there, reason about the cache usage and capacity of the line, reason about it definitively, clearly, and just let it move out from there, right? But start anywhere, just start. Don't think that you have to do all of it all everywhere, right? Find the most common case and start there. That's the process that we do. Figure out what the most common transform is and start there.
Thank you very much.
I like it, Ish. Finding that common case is not
I
easy,
just
but
wanted to make an observation. You said something about how this is not a new problem, not a new thing. Fred Brooks said a long time ago, show me your code, I won't know what you're doing. Show me your tables, which is COBOL speak for how you organize your data. I won't need to see your code.
Yeah, sure.
So
If I know what the input, I know what the output is, there's only so many ways I can get between them. Yes, this is not news, right? Absolutely.
thanks.
I know a lot of these
As
folks.
I was listening to your talk, I, excuse me, realized that you were working in a different kind of environment than I work in. You were working in a very time-constrained, hardware-constrained environment. As we all know, the hardware, when you specify the hardware as the platform, that's true because that's the API the hardware exposes. To a developer that's working inside the chip on the embedded code, that's the level at which is the platform. Ideally, I suspect that the level of the platform should be the level at which
You're
you can
interfacing.
abstract
Yeah.
your problem.
I know this gentleman, by the way. Sorry, his name's slipping my mind, but we would hang out at BoostCon and stuff. I really like him. I think he deeply cares. Anyway,
To the maximal efficiency. So I have a library, for example, that allows me to write code for both Linux and Windows. I have no problem with that. Our company uses primary constraint is engineering resources. I mean, we don't worry so much about the time because it's all user interface stuff. We worry about how long it takes a programmer to develop a piece of code in a given length of time. So we don't care about all that stuff. If we can write a map in one sentence and get the value out, we don't care really how long it takes, as long as it's,
Okay,
big
great.
of-
You don't care how long it takes. Great.
just need to pause this for a second. This dog he's trying to fall off the end of the. I'm saving him from himself. Okay.
But people who don't care about how long it takes is also the reason why I have to wait 30 seconds for Word to boot, for instance. But whatever, that's your constraint. I mean, I don't feel that's orthogonal to what we do. We worry about our resources. We have to get shit out. We have to make, we have to build this stuff on time. We worry about that. What we focus on though is the most valuable thing that we can do. We focus on understanding the actual constraint of the problem. Where can we actually spend the time to make it valuable for ultimately for our player or
Yeah, I think they're both sort of saying the same thing. I'm not sure, but I think what the gentleman asking the question, or rather rather making the claim, I think he's saying that my constraints are different, and so I wouldn't necessarily solve this because this is not what I'm being paid to do or what I'm being told to do. And I don't think that's wrong, right? I think that it just depends, right? It depends on the environment you're in. For example, like by the way, I absolutely agree with Mike. It drives me crazy when software systems are slow, especially my own software systems. Ooh, well, if you want to get under my skin in a major way, show me where my own software systems are slow, and I'm gonna just take this. I'm gonna fight this thing to the grave to fix it because I feel a responsibility, and so I like that this bothers Mike because I think it demonstrates ownership of the field and that he cares so much about the field that he's saying it should bother you because like stuff is slow and it's our responsibility to make it like less slow. And yes, sure. At the same time, for our jobs, when we're not like off being hobbyists in open source or whatever, sometimes we kind of just need to do the stuff that they're asking us, and we don't love it. In our heart of hearts, we think, "Oh, I don't know that this is good, but my boss is saying you got to do this thing, and I, that person calls the shot, so I'm just doing my job." Anyway, I that's my take on what they're saying.
or for whoever your user is. That's where we want to bring the value. And performance matters a lot to us. But I would say in any context, for me personally, if I was to be dropped into the business software development model, I don't think my mindset would change very much because the performance matters to users as well in whatever they're doing. That's my view.
I mean, that's why I love to code in C++ and why these are my people, right? I don't like non-deterministic garbage collection. I don't like handing it off to some other system that may or may not get it done in some period of time and just hand waving away performance stuff like it will just magically vanish. Something he said earlier is he said, I didn't totally love the way he said it, but the message of what he's saying, I think, is directionally correct, or it directionally aligns with me. He said something like, problems don't become simpler just because you want them to. Like, I agree with that. Complexity can't just vanish, right? Complexity is present. If you break a system down to its necessary components, complexity cannot go away. The only thing it can really do is move. It just moves from place to place. So in languages like C, C++, you have this memory they're unmanaged languages, right? So it's unmanaged. And then, so in languages like Java and Go and C# and stuff, they have a memory manager, but the complexity doesn't vanish. The complexity just moves. So rather than you dealing with it here, it deals with it here. And you just need to be okay with those trade-offs. Like, are you okay using a non-deterministic garbage collector? Okay, cool. Then there's your memory manager. If you're not, then don't. And then you don't get that benefit, but you also get the ability to not have non-deterministic memory signatures or behavior. And yeah, so it's just
Yes.
Hi. What do you think about portability? I mean, even in your area, I mean, you have to support the PlayStation 3, the PlayStation 4, the Xbox. There's differences. I mean, you're basically optimizing for one platform, right? So
Yes and no. I mean, we often do optimize for one platform, but we also optimize for a finite set of.
This is what I was saying. Is what I was saying. Now listen, yes, I already know ish where he's going. And yes, it is a finite set. But again, let's just be intellectually honest. The finite set of things like the PlayStation 3 to the PlayStation 4, PlayStation 5, this is a very small subset. And as we know, us gamers, we know, is Elden Ring going to run on the PS2? Let's guys, no lying, is Elden Ring with all of its shaders and all that stuff going to run on the PS2? We all know what the answer is. And so are you really targeting multiple platforms, or are you just targeting like basically the PS4 and the PS5? Just no fibbing. So it sounds like it's a set, but now when you target a platform in the past, like Ratchet and Clank, great game by the way, and then you want to modernize it to the latest and greatest hardware, not as hard. Why? Because you have more resources now than you did before. But if you try to do the inverse, if you try to take Elden Ring and say, all right, this is going to run on the PlayStation, the original PlayStation. I mean, maybe. I mean, look, I know there's some hardcore cheaters that are like, all right, challenge accepted. I'll do it. And I suspect you probably can. But let's be real. I'm already imagining the graphic fidelity, and it's just, you're not going to get the PS5 graphic fidelity. You can probably get the engine, right? Because the engine's not the core reason for the compute overhead. It's really the graphics processing, GPU and GPU stuff. But anyway, this is great. I haven't seen this part, so I had no idea it was going to go this way. And yeah,
Platform, right? Again, we reason about it. This is the range. You know, the range is not 6502 to sell, right? The range is smaller than that.
like one of the things I just, I can't help it. I'm sorry. One of the things that I try to do as maybe, I hope Alexi's watching this. I think Alexi's a really good example. Is Alexi comes at me, not hard, but pretty clearly on, he's not a fan of object-oriented programming language or programming paradigm. I don't try to argue against him. I don't try to say that the point he's making is invalid. Instead, I actually try to listen. I try to understand, what is he saying? Because he's a very smart guy, and he's deeply engaged, and he's sharing a viewpoint that seems different than mine. And I want to try to understand what he's saying, because if I think I already know the answer, like OOP is brilliant, and I already am the knower of everything, I might lose the opportunity to grow and hear something new. And so what I tend to find when I give talks like this, and I think if you search the interwebs, you'll see there's a lot of talks that I've given like this. The first thing I try to do is hear the audience. I try to hear and by the way, I promise I'm not beating up on Mike. This is a very hard thing to do, and I think he's doing a really good job. But I generally don't out of pocket disagree with people. This is just a rule that I take. First of all, I think about them, and it can be kind of scary sometimes to like stand up and ask questions. So I want to encourage discussion, not shut it down. Even if people are kind of like maybe a little aggressive. I got to be honest, maybe the first time Untranslatable Metaphor dropped something, it was like, okay, that's like a little intense, man. But his intentions are wholesome. And now he knows I'm listening to him, and he kind of like turns the heat down. Same thing with the Lexi. Same thing with Cyber. Same thing with all these folks. So this has nothing to do with Mike. This is more of a GTT thing. Is for those of you watching, this is something that I think really helps build community is to drive curiosity and move forward under the assumption that what we know or what we think we know could very well be correct for our circumstances, but they may not be correct for other people's circumstances. And so while the facts are potentially immutable, the agendas and the goals of different people, they're very much mutable. They're always they're very different. And so I would actually lean in. Like I would say, yeah, you're absolutely right. It is pretty constrained. Uh, totally. And so this is a small set of processors that this works in. And if you are in a very constrained space, I think this technique will work very well, especially if it's automated. But in the world at large, that has a lot more variability in hardware, I don't know. This might not work. We probably need to put our heads together and do some sort of experimental analysis to see. Like maybe that's the next thing that we work on. I don't know. That's the way that I would deal with it.
And so we can get something that works roughly well inside that range, right? We can reason about that.
Yeah, if you know that before, but say you wrote an engine for the PS3 and now you're moving it to the PS4,
Right.
That sounds like it's a lot more effort the way you do it than if you were.
Like the opposite, actually. You write the engine for the PS4, and then people want to make it work for the PS3. By the way, I know this guy too. Yeah, I just am terrible with people's names. Also, very smart guy.
Or just think about
The problem doesn't change. It's not the way we do it. It's what we do is solve the reality of the problem. The problem hasn't, the problem is that you've moved from PS3 to PS4. Like that's the actual problem. You can ignore the problem of what's actually on that hardware. That doesn't get you anywhere. You've just ignored it. Like, so
Where's the popcorn? This is awesome, man.
the comparison is if I ignore the problem, I get less, or if I reason about it, I could potentially at least get more. I'm gonna take door B, Bob.
So you've shown us some nice examples of transforming data, and I find that style of code is very easy to do a query or a transformation as long as you're dealing with almost absurdly simple data like an array. If you're dealing with an array, almost all these problems are very easy to solve. But if you have data that is too big to just fit in one big array, you need to start thinking about B trees and other more complicated data structures to manage access to memory. You can't just do a for loop. It's like it gets a lot more complicated in the
100% this is correct. This is so I don't even know what the question is, but what he's explaining is exactly why. I want to be super clear. This isn't even an opinion. This is more sort of like a fact. The reason why SQL is principally designed the way that it is, that you have like these joins and unions and all of this mumbo jumbo, and you cannot. Sorry, the dog's right next to me, and he's you cannot specify implementation details. You cannot. You cannot. The reason why you cannot do that, based on the people that I know that sort of invented this technology, is so you have freedom of hardware and that the system can be optimized appropriately for the different database. Specifically for what he's saying is once you get sufficiently large, like think about machine learning models today, specifically large language models. These do not fit on a single machine. It doesn't fit. So you have to use multiple machines. And now suddenly you can't rely on von Neumann architecture and a single cache line to improve things. You have to think in a distributed fashion. And the problem has actually changed because now your key constraint is probably more communication between nodes. That's the key overhead dilemma that you have, rather than how to sorry, the word's slipping my mind. Preload warm the cache rather than warming the cache. So I don't know what his question is, but the things he said so far is already factually sort of indisputable. This is not an opinion. This is just sort of like a fact of the world.
Code gets more complicated, and it's kind of like a
Complicated
problem, right?
Sorry to, if I can summarize what you're saying, hard problems are hard. Is kind of what you're saying, right? Yes, as data gets more complicated, the complexity of reasoning about it gets more complicated because the problem is harder.
What I'm saying is that even if you're thinking about data, like if the data is the problem, the representation of the data is also part of the problem. And
Of course
it'd
it
be
is.
nice if
I mean, you're
that
reasoning
makes
about how that data is accessed. You're reasoning about the cost of that access. Yes, that's the point. And more complex systems require more complex reason, right? You have to figure out, okay, well, I have a lot more stuff going on, whether or not, B tree is not a particularly complex example, but whatever you're working with and for whatever reason, you're doing a reason cost benefit analysis there. You're doing it for a reason, right? You're trying to get something out of it. And you have to reason about the cost of each one of those operations, how I'm jumping around this tree, how I'm analyzing the section of the tree, whatever you're doing. You have to be able to reason about those costs in order to know whether or not you're getting the benefit that you're trying to get by putting that structure there in the first place.
Mm. Mm. I think I'm going to end here, but I want to just share one high level thing. I work with a bunch of like really, really smart people, way smarter than me, just way smarter than me. And one of the things that I've learned is I may be pretty seasoned, I think, I'm just fiddling with the dog's collar while I'm telling you this story. I may be pretty seasoned in the things that I work on and the things that I am giving my attention. And that would kind of make sense. But one of the things that I've learned is I'm not thinking about all the things in the world. So when I work with really hyper intelligent people, what I try to do more is I try to listen. I try to understand, are they doing things that are maybe different than what I'm doing? I don't try necessarily to force my square peg into everybody's round hole. I try to figure out if my square peg will fit into their square hole, and if so, great. But then if it's a round hole, then I then will maybe start and say, well, this sounds like it's a round hole, and I have a square peg, so maybe there's ways to think about this to where we can change the square peg and we can change the round hole. We can figure out what is sort of immutable versus mutable. And then once we kind of understand that, maybe there's a way to kind of like maybe join these forces. So I think that's what I would say. Overall, I want to just share that I still, despite maybe I would probably handle the ending part different, but despite that, I think that there's a lot of really interesting stuff that Mike Acton has to share, and I really like the attention that he is bringing to this. In fact, in the talk that I just gave at Fastcode, they were asking me about performance engineering. They were saying, like, at the university level, what should we do? How do we change curricula and all this stuff? And I really think that we need to teach performance engineering in some way, irrespective of all the language models, because I don't think that critical thinking is just going to like stop. I mean, I'm terrified actually that critical thinking will just stop, and that's going to be bad for all of us. So the point is that I think language models can help us with sort of like the low hanging fruit, the stuff that's kind of easy, but the stuff that Mike's talking about, this is hard stuff. It's hard, right? It's so having us trained on how to make things potentially faster and better. I think that we want to keep doing this. We want to keep teaching like Mike is, but I think we want to teach in a way that expresses that some of the ideas that we have, they can work in really interesting spaces, but those spaces may be constrained. And that's totally fine if they're constrained. But I think we should be intellectually honest about the constraints that may exist rather than sort of demanding or presenting an argument where this is sort of like the way for everybody because I'm not sure, right? For example, even with C++, I love C++. I absolutely love it. It's the thing I want to code in. But I understand if people want to code in Python. I get it. Or JavaScript or other things. I get it. Like, in fact, Python is oftentimes the better choice just because you can, for things like rapid prototyping or just quick ideation. In fact, I'll even switch to it because it's just so dang fast. So I think that there's important things that can be gleaned here in how to build community and build bridges with folks. And having really good ideas is awesome, but then knowing that those really good ideas could perhaps be the foundation, but then the edges of those ideas might still require some refinement, right? Some mutability. Anyway, what do I know? I just talk about tech and hang out with the dog. The dog suddenly got super excited. Hey, buddy. All right. Thanks, everybody. And thanks, Gutsy David. This was super awesome. Please send more stuff like this. I really do love learning. So wonderful. Keep growing.